Okay, so let's take a look at an example where they've given us some restrictions on our function, some information about our function that we have to graph, okay? So it says here to sketch a graph of a function that satisfies all the given conditions, okay? So just to make our graph paper look a little clear, let's make that one, you know, like every other space. I think it'll just make our graph appear a little nicer. Okay, so let's read what we know. It says that the limit as we approach 0 from the left is equal to 1. Now, I'm just going to make these little teeny parts. Now, you have to remember, these are functions, so they can't overlap each other vertically, or it's not a function. Okay, so this is what I do to kind of counteract that. So when I'm coming in from the left, when x is 0, I'm at a height of 1. So I just kind of do an open circle and make a little tail. It can be coming up from below it or above it. I don't know. You'll see I'm heading from the left at x equals 0. I'm heading to a height of 1. Okay, so that's our first piece. Now let's look at this piece. As we are heading to 0 from the right, this time we are at a height of -1. So this time I make a little tail that goes like that. I don't know. I don't know where it goes. I don't know how long it is right now. That's all I know. Okay. Okay. Let's go back up. It says at 2 from the left, I am heading to a height of 0. That's what this next piece tells us. That as I head to 2 from the left, I'm heading to a height of 0. So again, I'm just going to go. That better? Okay. So I'm just going to go like this. Okay. As I head to 2 from the right, my next thing says that as I head to 2 from the right, I am going to a height of 1. F of 0 stays undefined, okay? The next thing said F, so I'm not going to color in any dots. I could have one of these dots colored in. That doesn't violate any rule, okay? But our function could, I don't know what our function does. I'm going to make it look more like a function. So that is one function that has all the markers that they have set up above. If you drew it and you drew it and you drew it, your functions might all look very different. You know, you might have a bump here and you might have up here and you might have went down here. That doesn't matter. All that matters are the limits that you have drawn. Do they fit the information they have given? Does that make sense how that was drawn? Everybody understand what we just accomplished? Okay, makes sense? And when I do this, I always go one more time after I've drawn it, and then I check, did it fit what I expected it to fit? One, is it still a function? Yes, I didn't make any of my lines overlap. Okay, that's good. And then I just kind of go through the pieces one more time. Have I come from the left of 0 to a height of 1? Oh, yep. Have I come from the right of 0 to a height of -1? Oh, yep. From the left at -2, do I have a height of 0? Yep. From the right, I'm at a height of 1. Yep. F of 2, oh, it is equal to 1. I was supposed to color that dot in. I didn't see that right there. So that one does have a colored in dot there. But F of 0 stays open circles. So yeah, everything that I wanted to be in my graph is there. Okay, does that make sense? So the graphs, your graph, my graph, they might look slightly different, but the characteristics that are most important have to be featured in the graph. And I think you do have one like this maybe for your homework. Okay, One last example for today are infinite limits. Remember how we talked about as you approach a vertical asymptote, you are either always going to go to positive infinity or negative infinity. So which one is it? So this is all about vertical asymptotes. So like for A, 6A, if I tried to plug in 5, I get 6 over 0, undefined. In B, when I try to plug in 0, undefined. C, when I try to plug in pi, undefined. So all those values are undefined values. There's technically a vertical asymptote at that point of the graph. So that means that at that point of the graph, whatever it is, so like number 5, or sorry, for 6A at 5, there's a vertical asymptote. So as I approach 5 from the left, I know, because I know there's a vertical asymptote there, I know my answer is either going to be positive infinity or negative infinity. But my job is to figure out, well, which one? Without graphing it, how can you tell? So here's the trick. So for 5, let's plug in 4.9, because that is slightly to the left of 5. I usually go a tenth. A tenth usually gives me enough information. It's usually close enough for me to determine what the heck is happening. Now, when I plug in 4.9, if I get a positive number, that tells me that I'm heading to positive infinity. If I get a negative number, the answer is negative infinity. So one, you have to recognize that's a vertical asymptote. And then you got to plug in something that's either to the left or right, depending on what the notation is saying. That's a negative. So that's to the left of 5, so 4.9. And then do I get a positive or a negative? If you plug in 4.9, you get 6 over 4.9 minus 5, which is 6 over negative 0.1, which is negative 60. That's a big negative number. That tells me the answer to this is negative infinity. So if we recognize that it's a vertical asymptote, and if we plug in something just to the left of the number we're approaching, if there's a little negative symbol there, and you get a positive number, it's positive infinity is your answer. If you get a negative number, it's negative infinity. I'm going to show you the graph momentarily here. If I can. Just a sec. It's like totally stuck. Here, I'll take a screenshot just a second. Yes, I will. Hey, there we go. Okay. So do you see the graph? Do you see how at 5, we are approaching negative infinity from the left, but positive infinity from the right, okay? So let's actually just take a minute and let's check from the right. So I want to do for 6a, I want to do the limit as x approaches 5 from the right. So for that one, I'm having issues today. For that one, let's plug in 5.1. So we get 6 over 5.1 minus 5, or positive 60. That tells me I'm going to positive infinity. So I just wanted to prove to you that if you just do my little trick, if you know it's a vertical asymptote, if you're coming in from the left, just do a 1/10 below it. If you're coming in from the right, just do a 1/10 above it. Okay, so at 0 for B, we have a vertical asymptote. But do you see how there's not a plus or a minus? When that's the case, you have to check both directions. Remember, a limit doesn't exist if it's not going to the same place for both directions. So what we're going to do for this one is, for B, I'm going to plug in into my function. I'm going to plug in, gosh darn, I'm having a moment. I'm going to plug in 0.1 coming in from the right. I'm going to plug in negative 0.1 so I can come in from the left. And I need to know, am I going to get positive infinity for both? So that's what I'm looking for. Am I going to get positive infinity for both? Okay. Well, if you plug in 0.1, I really only care about the signs of things. I'll tell you, mathematically, I just need to know, am I going to positive or negative infinity? So if I plug in 0.1 at the top, 0.1 minus 1, is that a positive or negative number? 0.1 minus 1, it's a negative. So I'm just going to put a little negative symbol. Okay, on the bottom, if I plug in 0.1, if I square it, still positive. 0.1 plus 2, still positive. Positive times a positive is a positive. What's a negative times, or negative over a positive, going to give me? Negative. So that side is going to negative infinity. Now we got to check the other side. The other side has to come to the same place, or there is no solution to this question. So we know the limit as we approach 0 from the right is negative infinity. Now let's check from the left. On the left, negative 0.1 minus 1 is negative. Negative 0.1 squared is a negative. Negative 0.1, no it isn't. It's a positive. Negative 0.1 plus 2 is a positive. We get a positive. We go to negative infinity. Only if both directions match do we say the answer is positive infinity. Otherwise, it would be undefined. Okay? Now, if you want to get the actual number in a calculator, you can, but you don't have to. Okay. Now, this next one, we're going to use a calculator. Now, remember, cosecant is the flip of the sine. We're coming in from the left of pi, and normally I do not change radians to degrees, but I am going to think of 180 degrees. To the left of 180 degrees is 179 degrees. Okay, because I just need to know what the heck that is. So I'm going to think, what the heck is the sine of 179 degrees? Is it a big positive? Is it a big negative? What the heck is it? So make sure your calculator is in degree mode. If you take the sine of 179, you get 0.017. So the cosecant of that is the reciprocal of that. There is a reciprocal button on at most calculators. That's that x to the -1 button. And so I can flip it with just hitting that button. And so I get 57.3, which is a big positive. So that one is going to positive infinity. A degree is enough to get you close enough to tell you whether you're going to positive or negative infinity, okay? If we were to look at a cosecant graph, first let me show you the sine. The sine graph looks like this. This is pi. Oh, you can't, can you? I don't know why it's all out of whack. But yeah, that doesn't completely help what it's not. Yeah, see the white there is what's recording. So it's just out of whack. I'm sorry. Anyway, if you look at this graph, that's the graph of the sine. The cosecant, remember, it's undefined here and here. And it bounces here. Shoop. And it bounces here. So do you see from the, gosh, I can't do that. I'm sorry. Anyway, you can see in the graph from the left of pi, we are going up to positive infinity. So see how we're going up to positive infinity, and that's what we predicted the answer was. Okay. So if you know the graph is the precise way to tell this, but I would like you to be able to do it algebraically, and that's the main issue. Okay. So that is all you need. There are some graphs here and some checking to see if something exists at a particular point. The solutions are under there so you can check your work when you're done. Okay, so there you go, do your thing.